Now we will see how to measure the potential. Suppose you have a magnet with you. You have a magnet, then you know that surrounding that magnet you have a magnetic field where the magnetism is felt. So we name that area to be the magnetic field of that magnet. Okay, and if I am placing another magnet or another magnetic material near this magnet, the magnetic material will experience a force. So, and if I am keeping the magnet far away from the magnetic material is kept far away from the magnet, that force won't be experienced. So the magnetic field is actually exerting a force on other magnets or other magnetic material. So same case we can apply for charges also. That is, if you are having a charge Q, surrounding that charge there will be an effect of this charge or influence of this charge. So that area surrounding that charge is called the electric field. Like magnetic field, we have electric field. And this electric field will be there for whether it is positive charge or negative charge. Field will be there. Wherever there is charge, a field will be surrounding that charge. Okay, and suppose I am placing another charge in this field. That is, I am going to place a charge plus Q dash. So you know the charges, if they are like charges, they will repel. So the charge will get repelled. Or if I want to move positive charge Q dash in this electric field, I have to do some work. That is, if I need to move, similar to that of the case of a magnet, we experience a difficulty in moving through the magnetic field. When we are moving magnetic materials in a magnetic field, we have to do some work. Similarly, if I need to move this charge Q dash in this electric field, I have to do some work. Similarly, if I am taking negative Q also, there will be an attraction between the positive Q and negative Q, and if I need to move negative Q from one point to another, we have to do some work. And one more thing is there, this charge, that is Q, so here our concerned charge is Q. So surrounding that, I told there are fields which are known as electric field. Now the field will be more or will be prominent near the charge, or we can say that there is a potential in this field. Okay, so that potential will be near to the concerned charge, and when we are moving away from the charge, we can see that the potential is decreasing. Okay, and if I am very far away, that is, if I am at an infinite distance, the potential experienced will be 0, because this point and the charge, they are at infinite distance. So if they are at infinite distance, the charge don't have any influence on that particular. If it is another charge, then it don't have any influence. So at infinite distance, we consider that the field is 0, or the potential is equal to 0. There is no potential at infinity. That is, if there is no influence of charge, potential at that point will also be 0. Now we are going to see how to measure the potential in terms of work. So I told that in order to move a charge inside the electric field, I have to do some work. So for understanding that, I am going to consider a space. So there are so many particles here. No charge is there. So if there is no charge, there won't be any electric field, and there won't be any potential also. Okay, so it is empty space. Now if I am going to place a charge inside this empty space, so here I introduced a charge let it be a positive charge or negative charge. It can be positive or negative. Let it be a charge q. Now so when this charge is placed, surrounding points will have what, the electric field will be created, and all these points will have that is at each of these points they will have a potential value for potential, and the potential will be maximum at the points near to the what, q, or the charge. And when we are moving away from the charge, the potential will decrease, or the influence of that charge will decrease. And if I am moving away, far away means if I am moving very far, the potential will be 0, or if I am at an infinite distance, the potential will be 0 there. Okay, so near the charge the potential will be more, and if we are moving away from the charge, the potential will goes on decreasing, and at infinite distance there won't be any potential due to our charge. So as I told, each and every point will be having different potential. So at one point this may be having one potential, one value of potential. Another point which is here, it may be having another value of potential. So let us see how to measure the value of potential. So suppose I want to measure the value of potential at this particular point. What we have to do is, so this here the potential is due to which charge? This q charge. Okay, so that is our field producing charge, and we are going to find out the electric potential at this point. Let it be A. I am going to find the electric potential at point A. For that, what you have to do is you have to take a unit positive test charge. Unit positive test charge means unit positive test charge. So test charge means it is a charge which we use for experimental purpose. Okay, so that we name that to be unit positive test charge. So unit positive test charge means the value of that charge will be 1 unity, and we are taking a positive charge, that is unit positive charge. Okay, so I am going to consider a charge with unit value, and I am going to bring this charge from infinity. Infinity means at a very long distance from the electric field. So I am going to take this charge from here to where? This point A. So from infinity I am going to take a charge with unit value and moving from there, and you know, when there is no influence it is easy to move. Once it enters the electric field, it will experience a force, and we have to do some work. That is, in order to move the charge inside the electric field, I have to do some work and should reach the point A. So this work, let it be W. Okay, so this work done by the unit charge is stored as potential, or we can say that the potential at point A is the work done in bringing the unit positive charge from infinity, that is from a very long distance, to that point A. Did you understand? I'll first write the definition and will explain to you once more. So we can define the potential at a point as the potential at a point if you are preparing the notes, you can write along with me so that it will be useful for your exams and all. Defined as, the potential at a point is defined as the amount of work done in bringing a unit positive charge. So unit positive charge means a charge which is having value 1 and the nature of charge is positive. So that is why we call it as unit positive charge. So from where we are bringing that? We are bringing it from infinity. From infinity. And to which point we are bringing? To that point. Which point? To that point where we need to find the potential. To that point. Okay, I hope you understood the definition. So when you define the potential, we can define it in this way. The potential at a point is defined as the amount of work done in bringing a unit positive charge from infinity to that point. So if you want to find the potential at any other point, let it be B. So if I want to find the potential at the point B, what you have to do? You have to take a unit positive charge from infinity, that is at a very long distance, and when you are bringing that charge from infinity to the point B, we will be doing some work. So that work will be stored as potential, and potential is represented using the letter V, capital letter V. Okay, so that is the definition of potential. Now let us look at the equation of potential. So here in the potential, main thing is we are bringing unit positive charge. Okay, in actual case, any amount of charge can be brought. So here, when you write the equation of potential, we can write that suppose W is the work done in bringing charge, work done in bringing a charge, and if Q is the charge which we are bringing, that is instead of unit positive charge, suppose we are bringing a Q charge from infinity to a point A or B or C or whatever be that, then we can define potential as potential V is equal to, potential is represented using the letter V, so you can write potential V is equal to, so it is work done per unit charge. So equation will be work done per unit charge. Okay, so the equation of potential is work done divided by the charge which is being brought from infinity to the concerned point. Now when you look at the unit of potential, unit of work, you know it is SI unit is joules, and unit of charge, it is coulomb. So the unit of potential will be joule per coulomb, and this joule per coulomb, it is known as, it is given another name, volt. Okay, so unit of potential is volt. Now we can define 1 volt here. What will be 1 volt? 1 volt, always when you are learning the unit, you have to define the unit. So what will be 1 volt? 1 volt will be 1 joule upon 1 coulomb. How can you define 1 volt then? So 1 volt will be if the amount of work done, if the amount of work done in bringing a unit charge, so here 1 coulomb means unit charge, okay, from infinity to a point is 1 joule. So if work done is 1 joule, we can say that the potential at that point is 1 volt. So once more, how will you define 1 volt? If 1 joule of work is done in bringing 1 coulomb of charge from infinity to a point, the potential at that point is 1 volt. That is the definition of 1 volt. So that is about the electric potential. Now next is potential difference. So once you know what is potential, it is easy to understand what is potential difference. So next is potential difference. So potential difference we represent it using PD. So difference in potential, from the word itself we can understand the meaning. Potential difference will be the difference in potential. That is, suppose we have an electric field, and if you have 2 points in the electric field itself, let the point be A and B. Okay, so let the potential at A be V1 or VA, you can consider VA and VB, then the difference in potential between them is the potential difference, that is VB minus VA or VA minus VB, whatever be that, that will be the potential. So that is the simple way of understanding the potential difference. So the difference in potential or change in potential between 2 points, we name that to be what? Potential difference. Now we have to define potential difference in terms of work done. So how will you define? So if you are having 2 points A and B in an electric field, so the potential difference can be defined in this way, that is, suppose I am taking a charge, that is unit positive charge itself, so unit positive charge means we can write it as Q. So for test charge I'll write it as unit positive charge. So if I take a unit positive charge from point A and bring it to point B, that is I am moving unit positive charge from point A to point B. For doing that I will do some work. So that work will be the potential difference between these 2 points. So how will you define potential difference? Potential difference between 2 points can be defined as the difference or the work done in bringing or moving a unit positive charge from one point to another. That is, if A and B is there, from A to B. So I'll define it once more. The potential difference, and I am just giving it as a PD. The potential difference between 2 points is defined as, so I'll write it as is the work done. Here also it is the work done. We have to do some work in moving the charge. So from where to where? Moving a charge, a unit positive charge. That is important. Unit positive charge. That is our test charge. Unit positive charge from one point to another point. Here the movement is between 2 points inside the field itself. From one point to another point. So that is the potential definition of potential difference. Okay, so the potential difference between 2 points is the work done in moving a unit positive charge from one point to another point. So if V1 and V2, suppose we have two points 1 and 2, and let V1 be the potential at point 1 and let V2 be the potential at point 2. That is, 2 points are there, like I said about A and B. Let it be V1 and V2. Then the potential difference V1 minus V2 will be equal to work done in bringing unit positive charge. So if I am moving Q charge, then work done by Q. Okay, if it is unit charge, then the work done itself will be the potential difference. So similar to the equation of potential, the potential difference also is the work done per unit charge, and the units are also same. Since work and charge is taken here, the unit of potential difference is also same as potential. Now you can even define 1 volt in terms of potential difference. That is, 1 volt, we know that it is 1 joule per 1 coulomb. So if you define 1 volt in terms of potential difference, how will you define? It will be if 1 joule of work is done for moving 1 coulomb of charge from one point to another point, then 1 volt potential difference is created there, or the potential difference will be 1 volt in such a case. So that is about the potential and potential difference.